Now problems on homogeneous system of linear equations. Once again, every homogeneous system is consistent. Means every homogeneous system has zero solution. System containing already indirectly it has zero solution. Means for some homogeneous systems there may exist non-zero solution, that is called non-trivial solution. Solve the system of linear equations. X plus 3y plus 2z equal to 0. 2x minus y plus 3z equal to 0, 3x minus 5y plus 4z equal to 0, and last equation x plus 17y plus 4z equal to 0. Solution. Given system of linear equations, I am writing here 4 linear equations, given linear equations. The above system can be written as Ax equal to b. A is nothing but coefficient matrix. Observe this one, 4 equations in 3 variables. A equal to coefficient matrix 1, 3, 2, 2 minus 1, 3, 3 minus 5, 4, 1, 17, 4. X is variable matrix x, y, z, 0 equal to 0, 0, 0, 0 matrix. Observe 4 equations, RHS side, every term is 0. Means we are not getting column matrix, constant matrix is 0 matrix. If constant matrix is 0 matrix, then that given system of linear equations are homogeneous system of linear equations. Now, for the homogeneous system of linear equations, I am considering the system Ax equal to 0. Now, R2 changes as R2 minus 2R1. Using first principal diagonal element, you make below elements as zeros. For making 0 elements, R2 changes as R2 minus 2R1, R3 changes as R3 minus 3R1, R4 changes as R4 minus R1. Observe this one. These are the important row operations. Every time we are using row operations only, because we are converting into echelon form. If you want to convert into echelon form, you should use only row operations. Then 1, 3, 2, 0, minus 7, minus 1, 0, minus 14, minus 2, 0, 14, 2 into x, y, z equal to 0, 0, 0. I am not explaining every time 2 minus 2, 4 minus 4. I am not explaining like that. I am writing here, after applying row operations, we are getting this matrix. If you want, you can check it. R3 changes as R3 minus 2R2. R4 changes as R4 plus 2R2. Why should I write these two operations? Because using second principal diagonal element, you make below elements as zeros. For that purpose, I am writing these two operations. Minus 14 is available. Then, if you want to make those two as zeros, you have to apply these operations. After applying these operations, 1, 3, 2, 0, minus 7, minus 1, 0, 0, 0, 0, 0, 0 into x, y, z, the column matrix is every time 0, 0, 0, 0. Now, rank of A equal to how much? Then second row, third row is 0 row, fourth row is 0 row. Number of non-zero rows are 2. Therefore, rank of A equal to 2 and n equal to 3. And one important concept, number of variables minus rank of the matrix is always number of linearly independent vectors. N equal to 3, rank of A is 2, 3 minus 2 equal to 1, means one linearly independent vector, we will get it. Now you multiply these equations after converting that system into echelon form. X plus 3y plus 2z equal to 0, minus 7y minus z equal to 0. Two equations in 3 variables means, if you want to calculate 3 variable values, then we need 3 equations. One equation is not available, only 2 equations are available. For that purpose, I will construct z equal to k, one parameter. And z equal to k, if you are substituting in second equation, minus 7y minus k equal to 0, y equal to minus k by 7. Substitute z equal to k and y equal to minus k by 7 in the first equation, then x minus 3k by 7 plus 2k, that equal to minus 11k by 7. X, y, z equal to minus 11 by 7k, minus 1 by 7k, k is common, minus 11 by 7, minus 1 by 7, 1. This is linearly independent vector. Otherwise, you can take k by 7 is common, minus 11, minus 1, 7 is the linearly independent vector. Means only one column vector we are getting here. 3 minus 2 equal to 1. That's why we are getting one linearly independent vector. Solve the system of linear equations. Lambda x plus y plus z equal to 0. x plus lambda y plus z equal to 0, and third equation x plus y plus lambda z equal to 0 if the system has 0 solution only. Now observe the system of linear equations. These are homogeneous system of linear equations. Every homogeneous system is consistent, means every homogeneous system has solution, that is 0 solution. Some homogeneous systems are containing 0 solution and as well as another solution also. That another solution is called non-zero solution, means that non-zero solution is also called non-trivial solution. And in the problem they have given this system has only 0 solution, means the determinant of A equal to 0, means rank of A is less than 3. If the suppose determinant of A not equal to 0 means the system has determinant of A not equal to 0. Now the above system of equations can be written as Ax equal to 0, where A equal to lambda 1 1 1 lambda 1 1 1 lambda. X is variable matrix, x equal to x y z, 0 equal to 0 0 0. If the system has non-zero solution, then we must have rank of A is less than 3, means the determinant of A equal to 0. If rank of A is exactly 3, means rank of determinant of A not equal to 0. Already the system has non-zero solution, means rank of A is less than 3 and determinant of A equal to 0. Now determinant of A lambda 1 1 1 1 lambda 1 1 1 lambda equal to 0, determinant of this matrix A. Now you convert this into, for easy calculations we are doing R2 changes as R2 minus R1, then here we are getting 0, here also we are getting 0, means in the second row third element, in the third row second element as zeros. We get first row as it is lambda 1 1 1 minus lambda, lambda minus 1 1 minus 1 is 0, second row. Third row 1 minus lambda 1 minus 1 0, lambda minus 1. Now from the second row I am taking lambda minus 1 common, from the third row also I am taking lambda minus 1 common. 1 minus lambda into 1 minus lambda into determinant of lambda 1 1 1 minus 1 0 1 0 minus 1 equal to 0. Now 1 minus lambda square into, I will expand the determinant along the first row, lambda into 1 minus 0, delete the first row first column, minus 1 into minus 1 is 1, 1 minus 0, minus 1 into, delete the second column and first row minus 1 into minus 1 minus 0 plus 1 into third element into plus 1 into, delete the third column first row, then it becomes 0 plus 1. Finally on simplification 1 minus lambda square 2 plus lambda equal to 0, lambda equal to 1 comma 1 comma and lambda equal to minus 2, means for lambda we are getting 3 values, lambda equal to 1 comma 1 comma minus 2, means if lambda equal to 1 then what type of solutions we are getting here. If lambda equal to minus 2, then what type of solutions we are getting here in this homogeneous system. Case 1, let lambda equal to 1, Ax equal to 0, then I will substitute lambda equal to 1, then 1 1 1 1 1 1 second row also, third row also 1 1 1 into variable matrix xyz equal to 0 matrix 0 0 0. Now I will convert this matrix into, if you want to solve the system of linear equation, the coefficient matrix every time you have to convert into echelon form. In the second row first element is 0, in the third row first two elements are zeros, because we have only 3 rows. Then R2 changes as R2 minus R1, R3 changes as R3 minus R1, then 1 1 1 1 minus 1 0 1 minus 1 0, everything to the second row and third row all the elements are becomes 0. X y z equals to 0 0 0. Writing in linear equations we get x plus y plus z equal to 0. Now observe this one, we have only one equation in 3 variables, but we have to calculate 3 unknown variables x, y and z, and from one equation it is impossible to calculate 3 values. That's why I will construct some equations from last z equal to k2 and y equal to k1. This is the rule. From last variable you have to you take one parameter, z equal to k2 is one parameter or some real number, y equal to k1, then x equal to minus k1 minus k2. Then you substitute x, y, z values in above equation, in above matrix. X equal to x, y, z equals to minus k1 minus k2, k1, next another one k2, z value is k2. Now k1 is common. When you are taking k1 is common, minus 1, coefficient of k1 minus 1, coefficient of k1 is 1. Again in the z, k1 is not available, that's why I am putting here 0, plus k2 equal to, now minus 1, for in y k2 is not available, I am putting 0. Now k2 is available here, coefficient of k2 is 1. Linearly independent solutions are these two, first k1 into something and plus k2 into something. Those vectors are nothing but linearly independent vectors. X1 equal to minus 1, 1, 0, x2 equal to minus 1, 0, 1 are linearly independent solution, and these two are the solutions of the above system of linear equations when lambda equal to 1. Now case 2, lambda equal to minus 2, then we can write it that you substitute lambda equal to minus 2 in the above system, then it becomes as minus 2, 1, 1, 1, minus 2, 1, 1, 1, minus 2 into variable matrix x, y, z equals to 0, 0, 0. Now if you want to convert into echelon form, if the first element is in the first row, first column, first principal diagonal element is 1, it will be easy for us calculation purpose. Then you can interchange R1 and R2, then it becomes 1, minus 2, 1, 2, minus 2, 1, 1, 1, 1, minus 2, variable matrix x, y, z equals to 0, 0, 0. Then while converting into echelon form, R2 changes as R2 plus 2R1, R3 changes as R3 minus R1. We get 1 minus 2, 1, 0 minus 3, 3, 0, 3 minus 3 into x, y, z equal to 0, 0, 0. Now in the third row, I need first two elements as zeros. Using principal diagonal element, you make below element as 0. R3 changes as R3 plus R2. We get 1 minus 2, 1, 0 minus 3, 3. Then it becomes 0, 0, 0. When you are adding those two rows, we are getting 0 into x, y, z equal to 0, 0. Now you convert this system into linear form, linear equations form. We get first row, first column, x minus 2y plus z equal to 0. Minus 3y plus 3z equal to 0. 0 into x is 0. I am not writing that part. Minus 3 into y, minus 3y, plus 3 into z is 3z equal to 0. Now this implies from the second equation, 3y equal to 3z, then that implies 3, 3 cancel, y equal to z. I am writing directly. Means two equations are available, but we have to calculate three variables. For that purpose, from z equal to, I will choose from last z equal to k. Y equal to z equal to k, means because z equal to y, therefore y equal to z equal to k, then x equal to 2y minus z, then 2k minus k equal to k. Therefore x is also k, y is also k, z is also k. Therefore variable matrix k, 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 k is common, 1, 1, 1. Then x equal to 1, 1, 1 is the linearly independent solution, linearly independent vector or non-zero solution when lambda equal to minus 2.